Join me as I take on the challenge of creating a stunning GUI from scratch on a Waveshare RP2350 screen using LVGL. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, Pico 2, Robotics, IoT and all things remixable tech. Today I'm diving into something I used to avoid, GUI design. But with LVGL on a Waveshare RP2350, it's not just doable, it's actually fun. In this video, you'll learn how to craft a slick, responsive GUI using LVGL, an open source powerhouse that makes embedded interfaces feel premium. We'll walk through setup, design tips, and how to make your interface pop without the pain. I used to default to web interfaces a lot and try to dodge that GUI headache. But with LVGL, well, it's a game changer. It's fast, flexible, and surprisingly quick. LVGL is a popular open source library that provides a wide range of features and tools to create stunning GUIs. It's highly customizable and supports various display drivers, making it a great choice for embedded systems. The Waveshare RP2350 screens are also amazing pieces of hardware, offering great performance and reasonable price tag. And when you put these two together, well, you've got a powerful combination of creative, impressive GUIs. Stick around as I explore LVGL's capabilities, streamline your setup and share design tricks to speed up your workflow. If this video sparks ideas or helps your projects, then hit that like button and subscribe to join the community. And if you want to support the channel, then drop me a super thanks or use the tips link in the description. It keeps the lights on and these videos flowing. Let's build something beautiful and without the usual GUI grief. Waveshare have a really good number of RP2350 and RP2040 touch displays. Now on this video I'm going to use the RP2350 Touch LCD 1.69, which is a 30mm by 32.6mm screen with 240 by 280 pixels, enough for a basic UI. Now this display has a USB-C, which is what I'm going to use to power it and to actually code it. But it's also got an RTC battery power connection on the back and a battery connection on the back if you want it. There is also some 2mm PCB edge connections there, though they are kind of hard to connect to be honest. But it has some connectivity, some other Waveshare boards have more. LVGL is a GUI framework. It's a framework for building UIs for embedded systems. It's been around since about 2016 and it's become one of the most widely adopted open source UI frameworks for embedded systems that's out there. Unlike, legacy solutions, that a lot of which have been adapted from the world of the desktop, LVGL was designed for embedded systems, and that makes it lightweight, flexible and efficient for those sorts of devices. And that's really important. It's also available under MIT license, which means we can use it both commercially and non-commercially, and basically just copying code into our projects as we wish. LVGL has been ported and is available on nearly all of the Waveshare displays, particularly the RP2040 and RP2350 displays that I've played with over the last several months and years. So what does LVGL provide us? Well, we've got graphical primitives and UI structures. We can draw lines and boxes, we can put buttons on the screens, we can put graphics on screens, and more complex controls like sliders or menus, etc. We can do image manipulation, so we can do chronographics, so green screening of images. We can change their size and dynamically move them around on the screen. It's got layouts, though often with small screens I don't really worry too much about layouts and fix things because there's not a lot of room for things to play around with. And you can animate things and of course an event system behind the scenes, because this isn't just about displaying things, this is about getting things back. And that means that when our users touch the screen, and manipulate our controls, we want to get events back to tell us what's happened. And that's really what LVGL is giving us. Okay, let's have a look at how Waveshare give examples for LVGL. And Waveshare are really good. They provide examples in both bare metal and LVGL, and for Arduino, for the Pico SDK C code, or Python or MicroPython for all of their boards. This one, of course, we're going to look at is the RP2350 Touch LCD 169, which is this board here, and we're going to have a look at the C folder because I'm looking at the Pico SDK. So let's have a look at the library folder first, because the libraries are what really are going to help us get to do the magic. And they've shipped with this a version of LVGL, and that's direct from the release on GitHub of LVGL. This one is version 8.1. Now the versions that you will get for each of the examples for the different boards are different. They tend to be version 8 based, so I've seen between version 8.1 and 8.4. Now the latest version of LVGL is well into the version 9. 8.4 is the latest version on the version 8 stream, and hasn't actually been updated for probably about 18 months. Moving it to 8.4 is actually trivial and easier, and I will show that in a little bit. Moving it across to version 9, that's not quite such a trivial migration, and it's not one that I've done yet. It's one that I've got in the back of my mind I want to do, but it's not one I've done yet. So I'll talk about version 8 in this. But this is absolutely 8.1. There's no alteration code. There's no configuration code in there. It is, you could dump a new version of LVGL 8.1 on there and it would work exactly the same. The other folders here are the various drivers for the hardware. So we've got the driver for the touch, QMI, that's the IMU, PCF, that's the real-time clock, the LCD chip and driver itself, and then configuration, which is sort of the adapter magic to allow those drivers to actually run on an RP2350 board and this particular 2350 board. And that's what they've put in there. In some of their boards, and I prefer this, they've combined all of those into a single folder and a single library. For this example, they're all split out, and that makes life a little bit more kludgy for us, I think. Especially when you start looking in these folders and find that, well, actually, there's only a single C file and a single header file in each one of them. So there's actually very little there. So when I'm going to work with it, and I will show you in my structure, I'm actually going to put them all into a single library, because that makes life a little bit cleaner and easier for me. So if we have a look at the makefile, we can see that actually that starts bringing in all of those subdirectories. It has to add all of the include directories for them separately, and it then has to add them all as target link libraries separately. We can clean this up a lot, honestly, and I'll show you that in a bit. So what's the code going to do? How's the code running? What's this example? How does it work? Well, main just calls test. So we better find test. Test is over in the examples folder, and in the examples folder there's a LVGL, sorry, there's that file there which has got test in it, and yeah, that's the test. So what does test do? Well, basically it goes through the initialization of all of those hardware chips, so the display, the real-time clock, the touch screen, the IMU, etc. Then it initializes LVGL itself, and then it does the really important thing. And if you take nothing else out of all of this spiel I'm doing, take it out that really the important bit, the only bit you actually need to really worry about, understanding, is widgets in it. Because that's what's going to paste everything onto your screen. That's what's going to set up all of the tiles, as they call them, and that's going to initiate most of the timers and animations that you're going to run. So the rest of this could be pretty much considered boilerplate. There is a loop down here with also a load of stuff that you don't need to worry about, and in fact doesn't actually even need to be there. That's up there. There is this one thing that you do need to call in a loop somewhere in your application that's giving it LVGL control of what to do, and it's called LV Task Handler, and that's really the poll function that you call to enable LVGL continuously. So let's see if we can find that widget's in it and see what that does then. So it's over here, buried with a whole load of other functions that you don't need to know about really, which is kind of unfortunate, and we can dig out when we do this. So widget in it is going to set up a bunch of styles for the example, and then it's going to start creating tiles. And a tile is basically the screen or the versions of the screen that can be actually scrolled left and scrolled right, up and down. So you basically can swipe the tile from one tile to the next, and that's what a tile is. And in this example there are 3 tiles, and it basically creates each tile and then it puts a bunch of objects on it. So the first tile is going to basically have the title image on it. Second tile is going to have a table with all of the IMU data on it. And where's the third tile? There's a third tile. And the third tile's got some example, another example table on it, by the looks of it. And there's a fourth tile, and that's gonna have some more. That's gonna have some sliders, and so that's the one that's actually giving you control to make some noise and play. So yeah, that's how it all works really. It's very simple, and it's all really about that function, and all of the adaptation inside that function to create tiles and to plate components onto those tiles. And it's that I think we want to extract out and be able to do ourselves in a simpler project structure. So this demo, we've got this image on the first tile. Then we've got a nice table there which has got all of the data coming from the IMU. If I turn it around a little bit, we can see them moving. So we're getting accelerometer data through. And then the next tile is the real-time clock. I haven't set it, so it's 1970. We're going back in time, it's fine. And then finally we've got a nice little tab that is going to make some beeps, which I've turned off because they're really annoying. So this is my project, my setup, and I've got a few experiments in here, so it's more than just a single project. So we've copied over the libraries here. So I've got the configuration, the LCD, the real-time clock, the IMU, and the touch. Now I've got a couple of JSON libraries here that I'm not using in this particular example. I'm using them in a later example in the video, so ignore them for the minute. And we've also got LVGL. Now this is version 8.4, because I said actually it's a drop-in replacement and it works just as well. Now I've put that in here as a submodule because I prefer to show traceability back to the original. Now it's an MIT licensed library, so you could quite happily copy and paste it, no one's going to complain. So in the experiments folder, then we've got our various experiments projects, and the one we're going to start with here is looking at LVGL simple. And I think this is a lot simpler, certainly in structure I think, than what we have previously. So we got the libraries where they were, and I've got first of all this touch169.cmake. So this is going to create a single touch 169 library that's got all of those components, libraries for the configuration, LCD, the real-time clock, the IMU and touch all in one place. Includes the source files, and indeed the link library requirements for those are all defined here. So once I've defined that and set that up, I can just treat it as a single include definition from my CMake, and this makes, I think, things a lot cleaner. So I can just copy this from project to project. And I've got the same for LVGL, where I've set that up, and we've got a library for LVGL. Now, LVGL does actually need to be configured or ported, if you like, is the word I tend to use. So there is a folder here called port, and in it there is a folder called LVGL, and this contains two really important tricks for us. The first, it actually configures LVGL, how we want it to work, what components we want turned on or not. Particularly the important one, I guess, I tend to end up going in here for is the which fonts I actually have available to me. So that's where the fonts will get turned on or off. So that's probably the biggest thing I jump in there for. Most other stuff stays the same. So configuring LVGL is important. The other thing is we've got to actually port it and adapt it to actually run on the board. And all of those interesting functions that we saw mixed in around the init function in the previous, or the widget init function in the previous example from our friends from Waveshare, well, I've actually put all of these in here in files called LVGL board, and they are then copyable from project to project. They're just all boilerplate, because everything in here is basically boilerplate that I should be able to copy from project to project. It's consistent porting of this board to run LVGL. So with those defined, and that's being picked up by a few definitions in here where I'm telling it where to find some of the folders, and then where, particularly for the libraries, because I'm running libraries in this in a shared model. I always write my library.cmake files so that they will try and find the library in the current folder, in the lib folder where it normally would live, and if it isn't there, then or the alternative is it will use a variable that I've defined. So there's a rather horrible kludge of lib path, I must admit, for the touch 169, and for LVGL it's more correctly the LVGL directory, which give those a hint of where to find stuff so that they can actually build those libraries. So our code then for our project is in the source folder. Now, of course, we do have another CMake files in here, and that's basically just defining the executables and giving the length libraries that we need. Now, because I'm inheriting those link libraries, and because I've defined these now as proper libraries, actually I only need to specify that I'm wanting 169 and the LVGL, and all of the other stuff like SPI, I2C, the PCM libraries all automatically get linked in because that's part of that dependency management system. So it makes this a lot cleaner in terms of its look. And then our executables, I've just got main, I've got widgets, which is where all that widget function is. And I actually have one image, and we'll talk about that in a bit, because that's all that this is going to do, is, as an example, is it's going to put a battery that looks like it's 100% charged on the screen. So let's have a look at main. So main is basically going to initialize standard I/O. It's going to initialize our board, and that board initialization now does all of the setup of all of those different chip functions. So the IMU, the real-time clock, the touch system, and the display driver. and indeed it initializes LVGL as well. And then I'm going to create a widget object, and I'm going to run the init on that widget function, and that is what is going to basically then paste all of the tiles and controls we want onto that display. And then we've still got our LV task handler function being called in our forever loop. So that makes all of that setup to run this as a project look a lot easier, doesn't it? So what's in the widget? Well, I've run this as a class, and I've written this as a class for a really good reason. Generally, when we've got a display, we want to do things to that display and change things on it, or react to touches of controls on that display. That tends to mean you need the handler to the LV objects a lot. So rather than having these defined and lying around in some global structure, I happen to have placed them in a class because that's the way I tend to like to work. You could have done them in a C structure and that would have worked just as well. But I think there are a lot of these things and you want to encapsulate them in something. And for me, that happened to be a class. So our widget init function is basically going to create our tile viewer and sets up the scroll, we'll turn scroll off for that, swipe still works, and then it's going to initialize the first tile. The first tile is going to create itself as a tile, and it's going to give its position 0, 0. So yeah, the first tile is always 0, 0. The first thing is the columns and then the rows. So if you wanted one to be to the right of the main tile, it will be 0 and 1. And then we're going to initialize a style for the background and set the style on the background, which basically I'm going to turn the background to black. And then I'm going to define our image, which is this battery 100. And then I'm going to create it as an icon, image icon, and I'm going to place that source of that battery image is going to be the source there for that image, where it's going to basically pull the instructions of how to draw a battery. And then I'm going to put it at position 80 by 0 x, y on this one. And that's it. And that's all we need to do to get a battery to appear magically on the screen. So here's the other magic. Now I didn't even draw that icon. I certainly didn't convert it. I didn't do any of the hard work. That was all done for me. And what I've done is use a couple of really clever little tricks here. Firstly is this site, gameicons.net, which will give me a whole load of icons which are ideal for my UIs. And they're all under Creative Commons Attribution license. So as long as I say where I've got them from, I can use them for my own purposes, and they're great. So I was able to go in here and find a battery. So, well, let's pick a 75% full battery. There we go. There's a 75% battery. Now I can now go in and change its size. So if I wanted it to be a little bit bigger, 200. If I wanted it to be a little bit smaller, 120. Now they are square sizing. So the one I've used, I actually did do some post-processing on because I actually wanted 60 by 120 rather than 120 square. But anyway, I can get an icon from here. I can even do stuff like change its background color. So perhaps I want to actually use the wonderful capability in LVGL to actually use a chromographic background and actually therefore make the background invisible. So I've set the background to be solid green. Now I probably then want the foreground to be a different color. Something that's a little bit more usable for me, so we'll make the foreground I don't know, nice and blue or something, and that would actually then give me just the blue icon, which I could then put onto a white background or any color background or any pattern background and have that there. I can even add things like text on here. So we could quite happily have a bit of text saying that it was 75%. We can put that on there too. Now, 7%, 75%. So we can do a lot of stuff in here, and then I can download this as a graphic. And then I've got a PNG. So the next part of the magic is over here with LVGL's owned conversion utility. So I can actually go in here and select my image, just the one I've just downloaded, nothing clever. There's my battery, and I can try that again. There we go, just the battery, nothing clever. And then I can say what format I want it. Now, to work with these images as they're downloaded, you want one of these, either a true color or one of these CF indexed values. These values don't have alphas in them, so if you start using alpha, you'll end up with just black. Now, I just put some extra colors in there, so 1-bit coloring would not work too well. But actually, for some of the icons and the icons I've done on my own projects, I actually use 1-bit because that saves a lot of space in terms of flash space for actually storing it. And for a lot of icons, they are only single color, or background and foreground color. So 2 colors, 1-bit. That's easy. But for what I've just put in there, probably we are looking at 2 or 4-bit. Actually, let's try a 2-bit. So I can basically set that up. I want the format to be a C array, and if I then put convert, what magically appears for me is a downloaded C file, and that's the C file I compiled with no alterations, nothing. I just placed it in that image folder, added it in my CMake file, and then referenced it in my code, and we're there. And it is that easy. So I really recommend this. This is so easy to get images onto your actually display through this process. So actually what I want to do on my dashboard display is actually to display a little bit more than just a single battery, because I want to have 2 batteries, and this is for RexB1, my little droid. So I'm going to have 2 batteries, and I'll be able to actually connect 2 drain sources from that, either to the CPUs or the drive system. And so I've got a little bit of an analysis and showing what's going on with those 2 batteries. One of them's being charged, one of them's actually draining, and how that's flowing through. This is basically just taking data off a serial port at the moment in JSON form, just to demonstrate that I can actually update those graphics and give myself a dashboard, and actually give myself a control screen as well. So okay, this is where things get a little more difficult and a little more real. So for my RexB1 droid, I want to actually have a touchscreen on the back that actually is just going to basically monitor batteries and give me battery status data, and allow me to actually do a little bit of power control to say where am I actually drawing battery power from. Is it going to be the battery 1 or battery 2? Do I want one of those batteries to be on charge at this point and put it onto charge, and those sorts of controls. So what I'm playing around with is, can I create a dashboard in LVGL to do that? Of course I can. So this dashboard is very similar in structure for everything you've just seen. The only thing here is there's just a lot more of it. And I'm also going to take some data in from externally to actually drive the dashboard. And so I've actually got some processing of JSON, which is what those JSON libraries were doing earlier. So main looks kind of a little bit more of a mess. This is a demo app just trying to get concepts working, but most things are the same here. There are a couple of differences. We've got something called a power state, which is basically all of the data in terms of booleans and values, float values that I want to actually put on the screen, and just actually, you know, the values of those rather than actually the widgets and stuff. And this is the data that's going to be passed over in JSON format. So the power state function knows how to convert itself into JSON and to update itself from a JSON message. And we're giving that over into our widgets because that's what's going to drive our widgets. And then there's in the loop, not only are we calling the tasks, but function from LVGL, but we're doing a bunch of stuff here, which is basically just reading in that JSON message on the standard input, or standard IO, and then it's actually, once it's got it all, it's passing it over to my power status functions or object, and updating that transaction from that, and that will then trigger the update to the screen basically. So it's basically reading the JSON in, giving the JSON over to the power state, and the power state then triggers an update on the screen. That's all that's there really. So I'm not going to go through how power state it really works, just except that it does. It's basically just a massive set of getters and setters on all of the values that are going to be on my screens, and then a bit of JSON processing, which you can do in both directions. The what else have we got in here? So then really everything else is back in our friend widgets. Now widgets has got a bit more complicated because we've got quite a few more controls that I'm putting on the screen, and in fact I've now got 3 tiles. Yeah, that's me playing around and trying to build that. And we also have some things now that read back. So I guess first of all we have, let's have a look at that. So our first tile, I put these now in reverse order, which is probably confusing. But our first tile is basically very similar to what you've seen previously. It's just a bunch of images placed around. There's just a lot more images. So we've got CPU, drive modes, the battery itself, all up there, and some labels as well, giving me the percentage fill of each of the batteries and the voltage on each of those batteries. And then when state happens and state changes, we get a notify event. I'm basically going and checking all of the statuses from that power state object, and basically updating what image is actually being displayed, which allows me to change the status on a nice dashboard. Now this whole dashboard then is not particularly interactive, it's actually quite static. And the reason it's quite static is because I don't want to tap it and cause something to change. So all the stuff that's going to be changing is actually on a second version of the dashboard, which has all of the actual button controls. And that is tile 2. And tile 2, instead of using images itself, as we did with tiles 1, and I've shown you, it uses image buttons. And that means that we can actually set both, or in this example, what I'm doing is basically set what the image should look like if the button is actually checked, i.e., you know, it's in latch mode or released. And that's what I've basically done with all of the status buttons. And that allows me to switch the icons and switch things around. And so that's what I'm playing with and using there. And then I do have the ability to read those and to send that data over to my server if I wish to as well, which I also wrote in here as a command handler, which should be down the bottom here. So yes, there's a click event handler. So if your handler happens to have a target of X play button, so which is to do something, then it will actually go and read off all of the values from the current controls of where do you want battery 1 to be driving the CPU or battery 2 to drive the CPU, etc. Puts all of that into a JSON message and sends it straight out of the standard out. Well, that's what it does at the moment anyway. LVGL really does make building GUIs quick and simple. Once you adapt to a clean project structure, then this becomes repeatable. Is that older version 8 LVGL product an issue? Well, I don't think so. I think I can build everything I really need on this version, and actually most of the bugs have been fixed there too. Yes, LVGL version 9 would be nice to have, and I'm thinking about a port project. That looks like quite a bit of time and effort though, and repeatable work for the different boards that I use as well. So I really need a project or a paid commission to prioritize that work. If you've got some ideas, then get in touch. If you like this video and it spikes ideas or helps your projects, hit that like button and join the community. And if you want to support the channel, then please do drop me a super thanks or use the tips link in the description. It keeps my lights on and helps me keep these videos flowing. Thank you very much for watching, and I'll see you on the next video. Bye bye.